Okay, let's finish this up for Monday's lecture here. Electric power. You can go look at the different sections there from the book. Basically, if we look at electric energy, it's the amount of charge added multiplied by the voltage, because voltage is just joules per charge. So if you multiply that as it's moving through there, assuming it's at a constant voltage, power is basically energy divided by time, the basic definition of it. So that's delta Q over delta T times delta V. But we also know that delta Q over delta T, symbol for that is I. So the rate that energy is being used up by a system, the power, is equal to the current multiplied by the voltage drop across whatever element is using up that energy. So it can be a resistor, it can be the battery, it can be pretty much anything. The units of power are called watts. They're joules per second. I'm named after James Watt. Basically, now that we have that equation, we could use it a lot of different ways. If we know current and voltage, just multiply them. But sometimes you know resistance, and not one of the other variables. So if we just combine delta V equals IR, we can just replace delta V here. We can get I times IR, which is I squared R. Or if we replace I, we can get delta V squared divided by R. So there are really three equations for power that are all the same thing. It's just the original equation for power combined with Ohm's law. Alright, so those of you who pay your own power bills have probably seen one of these or one of the new fancy smart meters. But basically what's going on is when you use electric energy, it records it. So the first dial goes, and every time this one goes around, it makes this one move once. And then when this one goes all the way around, it makes that one move once, and so on and so forth. Just like the dials on an old odometer. And as it's moving along, the more power you use, the faster this wheel's going to spin, which makes that wheel spin. But basically what's happening is it's counting how much energy you use. And because the joule is such a tiny amount of energy, they use a different unit of energy. So kilowatts, so thousands of watts multiplied by hours. So it turns out, if you figure out what that is, each kilowatt hour is 3,600,000 joules. So and each kilowatt hour in Bakersfield, depending on how much you're using, is somewhere between 10 and 25 cents. Right, so you see the idea of energy is power times time, kilowatts times hours. Right, this section is more the practical use section here. All right, that should be it for the lecture here. One thing I would like you guys to do is look around at some of the appliances you use and figure out how long you use an appliance, and see if you can figure out how much power it uses. And once that's done, you'll have that for class as well. Try and do 2 or 3 different appliances. It'll help with some examples. But I'll bring some examples here so you can figure out how much different things you use cost. All right, thanks a lot, and have a good weekend.